All right, welcome back. We're going to start by doing my favorite factoring, which is factoring by grouping. And I think it's my favorite because it helps us do the other factoring. If we can factor by grouping, then factoring regular trinomials will be easier because we'll have a surefire method other than guess and check. So let's hit it. 80. There we go. All right, so here are your steps. Basically, for what we're doing right now, we need to make sure it's written in standard form. So that means x cubed, x squared, x, and then our constant. This works for a 4-term polynomial only. So we can't do it the way it's set up for a trinomial. That we'll get to when we get to trinomials. But it won't work for 5 or 6 terms. It only works for 4 terms. So there are steps, split into 2 groups, factor out the greatest common factor of each group, and it is okay for that to be 1. And then I'm saying technically GCF again because you will hear me refer to this as inside outside. And I'm sorry that does not. For some reason it looks awkward, but that's because for some reason it wasn't writing. All right, so that's the basic steps. Let's do it so they make sense. So factor a cubic polynomial. Step 1, right, is to group. So I'm going to take the first 2, and I'm going to take the second 2, and I did this in my head, except there's a mistake here. This should be an n, not an x. So we have n cubed, n squared, n, so they're in descending order. So from here, I'm going to do the greatest common factor of the 3n cubed minus 12n squared. I know that my biggest number I can take out is 3, and my smallest exponent is 2. So from here, I'm going to factor that out. So what is 3n cubed divided by 3n squared? And that leaves us with 1n minus, because we're going to do negative divided by a positive, 12 divided by 3 is 4, and n squared divided by n squared is 1. So that's the first one. And then I'm going to do greatest common factor for my second group. And so what goes into both 2 and 8? And that is a positive 2. And from here, I'm going to divide by 2. So 2n divided by 2 is 1n, and 8 divided by 2 is 4. Now, here's where you can double check. I guess I forgot to write that. We're going to factor greatest common factor. Okay. You have the ability to know whether you factored out the biggest number or correctly, as long as these are the same. Must be the same. If they're not, either you didn't take out the biggest number or you divided wrong. So you just, and don't just say, okay, I've divided this out and I am left. Actually work through, because this is a very good place to check yourself. From here, this is where I call it inside, outside. In, out. Technically, we're doing greatest common factor because 1n minus 4 is on both of these terms. So I'm going to factor that out. N minus 4, which is my inside the parentheses, times, and then what's left is 3n squared plus 2. And so I took the inside, made it one of them, and then the outside became a set of its own parentheses. And so we end up with a final answer of n minus 4 and 3n squared plus 2, or times 3n squared plus 2, or you could write it 3n squared plus 2 times n minus 4, because multiplication is commutative. All right, so that's our first problem. From here, it should get faster. So again, we're going to group. So I group them. I'm going to do the greatest common factor. So what goes into 8 and 14? The answer to that is 2. And then t squared. And then from there, I am left with 4t, because 8 divided by 2 is 4, and t cubed divided by t squared is t. And then 14 divided by 2 is 7. T squared divided by t squared is nothing. So it's just a constant. Over here, 20 and 35, that means a 5 can come out. So I'm going to divide out 5. Now, if for some reason I can't think of what goes into both of those numbers, I know that it's going to have to match this. So I can say, okay, well, 20 divided by 4 is 5. So 5 has to come out of both of them. One way to think about it. So 20 divided by 5 gives us our 4t that we want. And then 35 divided by 5 is the 7 that we're looking for. And then inside, outside, so our inside, oops, there we go. Inside is 4t plus 7, and our outside is 2t squared plus 5. And that's the final answer. Now, I have added one last example, and the reason I added this example is because sometimes we have a greatest common factor to take care of before we factor. So if you notice, the first clue here is the fact that we have a q with all 4 of them. So that means we can take a q out to the front. But also 4, 8, 12, 24, that means 4 can come out of all of them. So after I take a 4q out, then I'm left with q cubed minus 2 cubed squared, q squared plus 3, ooh, don't do that on me, 3q minus 6. And that's what I have so far. I just took out a greatest common factor. Now from here, I'm just going to do the same steps as before. Group. I'm going to keep my 4q out to the front. I can take q squared out of this first group, and I'm left with q minus 2. I can take 3, positive 3 out of the second group, and I get q minus 2. And then keeping our 4q in front, inside would be q minus 2. Outside would be q squared plus 3. And that is our final answer. Now, if you're like, oh, but what if I don't know that I could take something out before? It's fine. Factor by grouping, and then what you will notice is when you get to the end, you can factor, we would have been able to factor 4q out of one of the 2 parentheses or factors at the end of the problem, and we could have done it, done another greatest common factor at the end. But that is factoring by grouping. And again, this is my favorite method. I will see you on the flip side, 8th graders. Stay classy.